Okay, here's our next video here. We're going to determine an angle in standard position when we're given a point on the terminal arm. We can also find the sine, cosine, and tangent values of that angle in standard position exactly. So for example here, point P is at -5 and -12. It's on the terminal arm of the angle in standard position. Well, where would that be? This point would be in quadrant 3. So if I counted to the left 5 and down 12, I'd end up with my point down here, -5, -12. And I'll draw that terminal arm right here. We've got to find this angle in standard position. We'll call it theta. So we've got to come up with a strategy to do that. One strategy would be, if I find this angle right here, the reference angle, and I add it to 180 degrees, I'm going to get the angle in standard position. So let's figure out a way to do that. I'll bring a line from point P up to the x-axis. We're going to create a little reference triangle here. This side length here is a grand total of 12 units long, because we had to go down 12 units. This side right here is a grand total of 5 units long. By the Pythagorean theorem, we could find that this length, the length of R, is equal to 13. 13. R is always positive. Now, we can find the sine, cosine, and tangent values of the angle in standard position. Remember, sine, that's the y-coordinate of point P over R. -12 over 13. The cosine, that's x over R. -5 over 13. And the tangent value, that's -12 over -5. Now, two negatives, they give you a positive, 12 over 5. We can use any of these to find the measure of the reference angle. The reference angle right here, we can treat this as a regular triangle here. We can use sine, cosine, and tangent values of the reference triangle. We find that the reference angle is 23 degrees. So the angle in standard position would be 180 plus 23 degrees. 180 degrees plus 23 degrees, which works out to, what is that? 203 degrees. That should help you with page 428, number 6, and number 10. Now, how do we find the angle in standard position if we're given the sine value, if we're given one of the trig ratios? For example, theta represents an angle in standard position between 0 degrees and 360 degrees. The sine value of theta is -2/3. Now, one thing we know about angles in standard position, there's two angles between 0 and 360 degrees that share the same sine value. Now, what does sine give us? Sine, that's y over r. If its sine value is -2/3, then we know that, r is 3. It's always positive. And the y-coordinate of point P is -2. So where do we find points that have negative y-coordinates? Those points are found in quadrant 3. Those points are found in quadrant 3 or quadrant 4. So we'll draw. From our quadrant 3, we've got an angle in standard position. We got a point. And we'll draw a terminal arm in quadrant 4. We're looking for that angle in standard position. Okay? Call them both theta. We'll make a little reference triangle here. We always want to make it visual. So I'll draw a line from point P to the x-axis. Well, we know that the length of R is 3, so we know that that's a total of 3 units long. Likewise here. We know that the y-coordinate of point P is -2, so that means we had to go over a certain amount and down 2. So we got -2 over here, and likewise -2. By the Pythagorean theorem, you would find that this length from here would have been √5 units long, and likewise √5 units long here. Point P here is at negative root 5 and negative 2. This point P is at positive root 5 and negative 2. All right. We could use this triangle here. We could find the measure of the reference angle. The reference angle worked out to approximately 42 degrees. So the angle in standard position would be 180 plus 42 degrees, which works out to 222 degrees. This reference angle, that is the same as this reference angle. They're the exact same triangle. So this reference angle is 42 degrees as well. The angle in standard position would be 360 take away 42, which works out to 318 degrees. Now how do you find the cosine and tangent values? Cosine, that's x over r. The x coordinate of point P, negative root 5 over r, which is 3. And the tangent value, that's the y coordinate of point P over the x coordinate of point P. Negative 2 over negative root 5. Two negatives give a positive, so we got 2 over root 5. Over on this angle, the cosine is positive root 5 over 3, and the tangent value is negative 2 over root 5. Negative 2 over root 5.